Hello, everybody. Welcome to your last lab. This week, we're going to be going over the ideal gas law. So the ideal gas law takes the form of this equation right here, where P is pressure, V is your volume in liters, N is the moles of gas that you have, R is the universal gas constant, and T is your temperature in Kelvin. You should be pretty familiar with all these things except maybe R, the universal gas constant. So the gas constant is, as the name implies, a constant. It always has the same value, but there are several different R values depending on which units of pressure you use. As I had mentioned, your volume is always going to be in liters, and your temperature is going to be always going to be in Kelvin, and moles will always have the units of moles. But your pressure can actually have several different units depending on which you use. You can use atmospheres, which is ATM, pascals, kilopascals, millimeters of mercury, torr. You have several options. And so there are actually lists of gas constants out there, but the ones you're most commonly going to use are this one right here, 0.08206 liters times ATM. So you use this whenever your pressure is in the units ATM, or 8.314 liters times kilopascals, which you would use whenever your pressure is in kilopascals. I believe in this lab, y'all will be recording your pressure in kilopascals, so you're going to use that 8.314, our universal gas constant, if you want to do any sorts of calculation. There's a lot of power in this equation and showing us how gases behave. Let's say, for instance, that we hold our pressure constant and the number of moles constant, but we vary our temperature. Let's say we increase our temperature. So if we increase our temperature on the right side of the equation, and this is constant, and this is constant, we know that our volume has to also increase in order to keep this equation true. To use another example, let's say we keep our volume constant and we keep our temperature constant. And so if we decrease the number of moles in a container, we'd also decrease our pressure as a result. So you can see that whenever something changes on the right side, we get the exact same effect on the left side. But let's say, for instance, we keep our moles and our temperature constant and we increase our temperature. Well, the only way to keep this equation true is if our pressure goes up, our volume has to go down as a result. So you can learn a lot of things based off this equation. But you should note that there are a few assumptions we use whenever we use ideal gas laws. The first of which is that there's completely random motion in the container which holds the gas. The second is that the volume of the molecules themselves are so small that it doesn't matter when it's compared to the volume of the container that the gas is occupying. That's the second assumption. And the third assumption is that all of the collisions occurring in the container are elastic, which is to say that no energy is lost. Whenever one molecule hits another, it transfers all of that energy into the next molecule. So if those three assumptions are true, then our ideal gas law is also true. So there's some background for your lab report. This may be very helpful for writing your introduction. Let's go over the procedure a little bit. So the first part of your experiment, you are going to place some sodium bicarbonate into an Erlenmeyer flask, and you are going to have some acetic acid in a syringe. And you will also have a pressure sensor that attaches to a rubber stopper in your flask. That way, we're keeping our volume constant here. So what you do is you're going to inject your acetic acid in, and it's going to react with sodium bicarbonate, and it's going to release carbon dioxide. In fact, this top equation here is exactly what you're going to be doing. You'll have your acetic acid, sodium bicarbonate, and the only gas you're going to make is carbon dioxide as a result. So we go from having a certain number of like air molecules within this container, but then we're making a gas from a liquid and a solid. So you will see that your number of moles is increasing inside this flask. So what should happen to your pressure as the moles of molecules go up? So pay attention to that. Once you have finished that, you're going to keep your Erlenmeyer flask sealed. We have to keep the moles of gas constant for the next step. And what you're going to do is you are going to take your flask and submerge it into an ice water bath. And you should see that something happens to your temperature because now we're keeping our moles constant and we're keeping our volume constant. but we're decreasing our temperature. So you should see a change in pressure as a result. And that's pretty much your entire lab. You're going to have to do the first part a couple times. You have to do it 3 times. But the second part you only do once, where you decrease the temperature. So your lab is actually very straightforward. It's pretty quick. Um, so it should be pretty easy to get through. So let's talk about your lab report this week because y'all are doing a full lab report. So you need to make sure that you're answering all parts of what we expect for each portion of a lab report. So first of all, your title. You need to have some sort of title. It needs to be descriptive, telling us what exactly occurred in the lab. Maybe some of your results could be in that title. So it can't just be carbonation release or ideal gas laws. You need to have some sort of descriptive title. Then you're going to have your introduction, which needs to both have background and hypothesis. So I just gave y'all a bunch of background at the beginning of this video, and you can incorporate all of that into your report. You do need to have sources for your introduction usually. If you're going to be talking about background, you need to cite some article. So please remember to include your references. And then you also need to have a hypothesis. What do you think is going to happen at multiple points in your experiment? Hopefully this week I will remind y'all to make a hypothesis before you start the lab, but if you didn't do that, then just make a hypothesis right before you write your introduction. So make sure you have background and hypothesis. Next, your method section. This is just simply talking about what you did in the experiment. It cannot be a straight copy and paste from your procedure here, and it also cannot be in a list or bulleted. It needs to be in complete paragraph form to receive full credit. Next, your results section. So you need to have a table or figure showing your data. It should be very easy to make a table or figure because this week y'all are going to be using your lab quest one last time. And so you will have plenty of data to turn into a graph to show pressure as a result of temperature or pressure as a result of number of moles. So please include those here. Make sure not to have any discussion of your results in this section. It just needs to be purely what your data was. Interpretation comes next. For your analysis and discussion, you need to analyze your results. Do your results line up with the ideal gas law? What's occurring in that flask? Why is it that whenever the temperature goes down that we see a decrease in pressure as well? So you need to make sure that you not only understand the ideal gas law, but understand it at a molecular level as to what is happening to the molecules. And then finally, your conclusion should summarize what you did in the lab. So briefly talk about your results one last time, and then talk about how that links to the introduction, say whether or not hypothesis was correct or not. And then also, I did forget your references. So anytime you were supposed to reference something, you need to have your reference down here. It needs to be in ACS format. And that covers your lab. So if you all have any questions, please let me know. And congratulations on making it to the end of the lab.